6825. As the CG location is changed, recovery from a stall becomes progressively A. Less difficult as the CG moves rearward. B. More difficult as the CG moves rearward. C. More difficult as the CG moves either forward or rearward. The correct answer is B. As the center of gravity, CG, location is changed, recovery from a stall becomes progressively more difficult as the CG moves rearward. The correct answer is more difficult as the CG moves rearward. When the CG of an aircraft is located aft, it shifts the balance point towards the tail, causing the aircraft to be less stable. This has implications for stall recovery. A stall occurs when the angle of attack of the wings exceeds the critical angle, resulting in a loss of lift. During a stall, it is crucial to recover promptly by reducing the angle of attack and increasing the airflow over the wings to regain lift. However, with a rearward CG, the aircraft's stability is compromised, and the recovery process becomes more challenging. An aft CG position can lead to a nose-up pitching moment during a stall, making it more difficult to lower the aircraft's nose and reduce the angle of attack. The reduced stability increases the risk of the stall persisting or developing into a spin. Conversely, when the CG is located within the proper limits or towards the forward limit, the aircraft's stability is enhanced. This facilitates the recovery process from a stall as the aircraft has a natural tendency to lower the nose and regain lift more effectively. Therefore, as the CG moves rearward, the recovery from a stall becomes progressively more difficult. It is important for pilots to operate within the specified CG limits to maintain optimal aircraft stability and improve the chances of successful stall recovery. 6826. What is the effect of center of gravity on the spin characteristics of a fixed-wing aircraft? If the CG is too far? A. Aft, a flat spin may develop. B. Forward, spin entry will be difficult. C. Aft, spins can become high-speed spirals. The correct answer is A. The effect of the center of gravity, CG, on the spin characteristics of a fixed-wing aircraft is such that if the CG is too far aft, a flat spin may develop. The correct answer is aft, a flat spin may develop. During a spin, an aircraft experiences an uncoordinated stall condition where one wing is more stalled than the other, resulting in an auto-rotation around the vertical axis. Spins can be categorized as either flat spins or erect spins, depending on their characteristics. When the CG is located too far aft, it shifts the center of mass towards the tail of the aircraft. This has a destabilizing effect and can lead to a tendency for the aircraft to enter a flat spin. In a flat spin, the aircraft rotates almost horizontally with little or no nose-down pitching tendency. This type of spin is characterized by a more rapid rotation and a flatter attitude, often making it more difficult to recover from. Conversely, if the CG is too far forward, it can affect the aircraft's ability to enter a spin. Forward CG positions can result in more stable flight characteristics and make it more challenging for the aircraft to enter a spin. It's important to note that the CG position specified by the aircraft manufacturer must be adhered to in order to maintain safe and predictable spin characteristics. Operating outside the recommended CG limits can significantly affect the aircraft's stability and controllability during spins and other flight regimes. Therefore, if the CG is too far aft, a fixed-wing aircraft may be prone to developing a flat spin, which can be more challenging to recover from compared to other types of spins. 6817. The stalling speed of an aircraft will be highest when the aircraft is loaded with A. High gross weight and aft CG. B. Low gross weight and forward CG. C. High gross weight and forward CG. The correct answer is C. The stalling speed of an aircraft will be highest when the aircraft is loaded with a high gross weight and forward center of gravity, CG. The correct answer is high gross weight and forward CG. Stalling speed is the minimum speed at which an aircraft can maintain controlled flight without experiencing an aerodynamic stall. It is influenced by several factors, including the aircraft's weight and CG position. When the gross weight of the aircraft is high, there is an increased load on the wings, which requires a higher speed to generate the necessary lift to counteract the weight. This results in a higher stalling speed. As the weight of the aircraft increases, the wing loading also increases, requiring a higher airspeed to maintain lift and prevent a stall. Additionally, when the CG is located forward, the aircraft's longitudinal stability is increased. This means that the aircraft's nose has a natural tendency to pitch down, requiring a higher angle of attack and airspeed to maintain level flight. As a result, the stalling speed is further increased. On the other hand, when the aircraft is loaded with a low gross weight and a forward CG, the overall weight and wing loading are reduced, resulting in a lower stalling speed. Similarly, a high gross weight and an aft CG can also decrease the stalling speed, but can lead to other stability and control issues. It is important for pilots to be aware of the effects of weight and CG on the stalling speed of an aircraft, as operating beyond the specified weight and CG limits can significantly affect the aircraft's performance, handling characteristics, and safety margins. 6819. If the CG of an aircraft is moved from the aft limit to beyond the forward limit, how will it affect the cruising and stalling speed? A. Increase both the cruising speed and stalling speed. B. Decrease both the cruising speed and stalling speed. C. Decrease the cruising speed and increase the stalling speed. The correct answer is C. If the center of gravity, CG, of an aircraft is moved from the aft limit to beyond the forward limit, it will decrease the cruising speed and increase the stalling speed. The correct answer is C. Decrease the cruising speed and increase the stalling speed. The position of the CG has a significant impact on the aerodynamic characteristics of an aircraft. When the CG is located beyond the forward limit, it means that the aircraft is nose-heavy, with a larger proportion of weight concentrated towards the front. Cruising speed is influenced by the aircraft's balance between lift and drag. When the CG is beyond the forward limit, it shifts the aircraft's aerodynamic center forward, which reduces the effectiveness of the tail surfaces in generating downward force to balance the aircraft. As a result, the tail's ability to counteract the nose-down pitching moment is reduced, and the aircraft's nose tends to pitch downward. To counteract this, the pilot needs to apply more elevator control input, which increases the overall drag and decreases the cruising speed. Stalling speed, on the other hand, is the minimum speed at which an aircraft can maintain controlled flight before experiencing an aerodynamic stall. When the CG is beyond the forward limit, the aircraft's longitudinal stability is increased. This means that the aircraft's nose has a natural tendency to pitch down, requiring a higher angle of attack and airspeed to maintain level flight. Consequently, the stalling speed is increased because more lift is needed to counteract the additional downward pitching moment caused by the forward CG. Therefore, when the CG is moved from the aft limit to beyond the forward limit, the cruising speed will decrease due to increased drag, and the stalling speed will increase due to the need for a higher angle of attack and airspeed to maintain lift and prevent a stall. 6820. When an aircraft's forward CG limit is exceeded, it will affect the flight characteristics of the aircraft by producing A. Improved performance since it reduces the induced drag. B. Higher stalling speeds and more longitudinal stability. C. Very light elevator control forces which make it easy to inadvertently overstress the aircraft. The correct answer is B. When an aircraft's forward center of gravity, CG, limit is exceeded, it will affect the flight characteristics of the aircraft by producing higher stalling speeds and more longitudinal stability. The correct answer is higher stalling speeds and more longitudinal stability. The position of the CG plays a crucial role in determining an aircraft's stability and performance. When the CG is located beyond the forward limit, it means that the aircraft is tail-heavy, with a larger proportion of weight concentrated towards the rear. Exceeding the forward CG limit has several effects on the flight characteristics of the aircraft. Firstly, it leads to higher stalling speeds. Stalling speed is the minimum speed at which an aircraft can maintain controlled flight before experiencing an aerodynamic stall. With the CG beyond the forward limit, the aircraft's longitudinal stability is increased, causing the nose to have a natural tendency to pitch down. This requires the aircraft to fly at a higher angle of attack and airspeed to maintain level flight, resulting in higher stalling speeds. Additionally, exceeding the forward CG limit enhances the aircraft's longitudinal stability. Longitudinal stability refers to the aircraft's ability to maintain its pitch attitude without excessive pilot input. With the CG located aft of the forward limit, the aircraft's nose tends to pitch down, which increases the longitudinal stability. This can make the aircraft more stable and less prone to pitch changes, but also results in decreased maneuverability and a potentially slower response to control inputs. It's important to note that while increased stability can be beneficial, exceeding the forward CG limit can also have disadvantages. For instance, it may result in very light elevator control forces, making it easier to inadvertently overstress the aircraft. Pilots must be aware of the specific CG limits and adhere to them to ensure safe and optimal aircraft performance. Therefore, when an aircraft's forward CG limit is exceeded, the flight characteristics are affected by higher stalling speeds due to increased angle of attack requirements and more longitudinal stability, which influences the aircraft's pitch behavior.